So we're going to talk about absolute value, and it's called a parent function. We have done parent functions before. We just didn't know what they were always called. So what we're going to do is we're going to look at that. So you remember what an absolute value is. An absolute value just means what's the distance from 0. So for instance, if I put in the absolute value of -3, I'm going to get 3. Okay, because what's the distance? And if I put in absolute value of -2, I get 2. You see what's happening here? Okay, so the absolute value of 3 is 3. So if I were to graph this now, I'm going to take and plot the point -3, 3, -2, 2, and it would be like this. It would look like a V shape, and we would draw that line. Okay? This is an absolute value function, and this is called the parent function. So it's a parent function if it's just the basic function. So this is a parent function. So now let's look at the domain and range. Okay, so the domain, are there any restrictions on what I can plug in for x? No. So this would be all real numbers. Okay, and what about the range? Well, look at what your range does. It starts right here and it goes up. All the y values from here on up. So we could write that as y is greater than 0. If we were doing an interval notation, it would go from 0, and this time 0 could be included, all the way up to infinity. But this is the parent function. And usually we concentrate on basically these 5 points here when we're talking about a parent function. A lot of times that will tell us everything we know. Okay, so describe the shape of this. It's a V shape, which is really helpful because then we know that an absolute value is a V shape. What is the vertex? Well, the vertex is kind of like a turning point. Where does the graph start going the other way? So it's a turning point. So this is going to be my vertex. Now your vertex is always going to be the lowest point or the highest point. Now, when I say highest point, and you're going, well, wait, it just keeps on going and going and going. If I'm looking at the graph, my lowest point is my vertex. We will learn later on that our graphs can open down. They can have a point up here and go down this direction, so then it would be the highest point. The axis of symmetry. Now, the axis of symmetry is a line that divides the shape in half. It makes it so it's symmetrical. So my axis of symmetry on this one is going to be the y-axis. Now it's not always the y-axis, and I know you can't see what I'm drawing on. Let's see if I can do it in a different color if it shows up any better. But this would be my axis of symmetry. Your axis of symmetry is always going to go through your vertex. Will go through vertex. We're going to talk about that on the absolute value and also on when we talk about a quadratic, which is what we're going to be doing the next lesson. So we're going to go out to Desmos and we're just going to experiment with this and see what is happening. But I want you to just look at these functions. So this is the parent function. This is the parent. Okay, and then these are what are considered the offsprings. I'm sorry that one ended up down there. I apologize. But look at this. Think about what we did with all of our other graphs. What would be your prediction as to what would happen? Yeah, think about that. Now, I will tell you too, on your keyboard, if you want to type it in, the absolute value is the line right underneath. You're going to have to hit Shift in order to get to your absolute value, and it's right underneath the backspace. So let's go out to Desmos, and what I want you to do is I want you to go out to Desmos, and you're going to take like about 5 or 10 minutes, and whatever you need, plot the parent function. Always plot the parent function, and then plot this function. What do you notice? Okay? Pay attention. And you might want, and you could even do these because just make sure they're in different colors. So each one of them is a different color. So go out and plot these in Desmos, and I'll remind you how to do that. Okay, so let's go to desmos.com. Okay, so out on desmos.com, I'm going to bring up the keyboard because I guess I'm going to use it. So I'm going to use Y, and I'm just typing it in equals, and I'm going to type in the absolute value. So shift, the button right underneath the backspace, X. Now, I'm sure they have an absolute value on here too. Let me see. So you can see the absolute value is right here. So I don't even have to do what I did. But you can see you can also type it in. So for this one, I'm just going to finish it. There we go. There's my absolute value. Oops. Let's get rid of these functions. Okay. So now I'm going to put in the next one. Y equals. And now I'm going to hit the absolute value button. And put it in that way. Okay. So X, absolute value, and then +1. Remember how to do this, and you can always use your keyboard down here. Okay, look at that, see what's happening. Okay, go, do the rest of it. And if you want to, change your functions to whatever you want to, but play with it, and changing that number on the outside. Leave this absolute value part right here, leave this absolute value part, and change this to minus or plus, change this to number, whatever you want to. And then come back and let's talk about what happened. So this is what mine looks like once I've graphed all 4 of those equations. And the red one is the parent function. The red one is the parent function. So if you haven't already, answer the questions on the sheet right under this. It says, what happened to the graphs compared to the parent function f of x equals the absolute value of x? What happened? What did the graphs do? How did the axis of symmetry change? Did the vertex change? What about the domain and the range? Okay, so if you haven't yet, answer those questions. So hopefully you wrote down what you saw happen with the axis of symmetry, what happened overall, how did the vertex change, domain, and range. So what I'm talking about is how did the vertex, not the vertex, how did the graph? So the red one is the parent function. How did these change? Well, notice they just shifted up and down. Okay, so they just shifted up and down. And how do they shift up and down? If I'm going from the red vertex, look at my equation over here, the red graph up to the blue graph, what happened? It went up by 1, didn't it? Look at what happened on the green one. What did it do? It went down by 5. Okay, what about the purple one? It went up by 8. Okay, so did my axis of symmetry change at all? Nope, it stayed right there. It's the y-axis. What about my vertex? Did my vertex change? Well, yeah, my vertex changed by however many it went up and down. So the x value did not change, but the y value changed on all of them. Okay, see how the y value here is 0, 0. Here it's 0, 1. Here it is 0, 8. Oh, and look, it even shows up with a little ordered pair. And of course, 0, -5 down here for the green one. So your vertex changes. What about your domain? Is there any restriction on my x value? Nope. What about my y value? Well, yeah, of course it changed. Because look, on my red graph, it went from 0 on up. On my blue one, it went from 1 on up. On my green one, it went from -5 on up. So your domain and your range changes. Okay, I'm going to go write that all down. Okay, so how did it change in comparison to the parent function? Well, this one went up, 1. This one went down, 5. This one went up, 8. Okay, so what happened? It shifts it up and down. Did my axis of symmetry change? No, not at all. What are my vertex? Yes. The x value stayed the same. The y value changed by whatever I was moving it up and down. So my vertex just went and changed by whatever that value was right here. What about my domain? Is there any restriction on the x? Nope, no change. So that means it's all real numbers. And my range? Well, it changed because my y value changed. If my y value changes, my range is going to change. So here it went up 1, here it went down, and so it went from -5 on up. Here it was going to go from -5, including -5, to infinity. Here it goes from 1 to infinity. Here it goes from 8 to infinity. Okay, so yes, it changes by the shift number, the number that it shifts, by the number that it shifts. I'm sure there's a more elegant way to say that. Okay, now I want you to go back out to Desmos. I want you to keep the parent function, but I want you to change this. And again, look, all I'm doing is I'm putting a plus or a minus there, and I'm changing this number. So go out and play with that and see what happens. Go to Desmos and do those. Go. So hopefully you've graphed this. The red one is the parent function, okay? And I'm just going to zoom in a little so we can see these a little better. Oops, not that much. Okay, so on the first one, x plus 3, that's the black one. So here's my parent function, which is red, and when I go and I move it, look, it moves to the left. And how many did it move to the left? 1, 2, 3. So look at that x plus 3. What did it do? Okay, this might sound familiar because we've done some of these before. Now x minus 2 is the green one, so here the red one is my parent function, the green one is my new one. And then the blue one is x minus 5. Okay, so again, go to your paper. What happened to the graphs compared to the parent function? So compared to this red parent function, what did they do? And you can even do it for each one. You'll notice that I added this one in. Feel free to add anyone's in you want to, okay? Did the axis of symmetry change? Answer that. Did the vertex change? Answer that. What about the domain and the range? Did that change? Okay, so go and answer those questions, please. So hopefully you actually paused this video and you went and wrote down those answers. If not, you can do it right now. Okay? So your axis of symmetry, okay, on your parent function is just the y-axis. But look at the black function over here where it moved over 3 to the left. My axis of symmetry has actually changed to the left also. If I look at my green one, my axis of symmetry now goes right through there. Okay, look at this axis of symmetry. So did my vertex change? Yes, it did. Did my domain change? No, I can still plug anything in from my x. And here's the interesting thing on this. I didn't have a shift up or down, so therefore my range just goes from 0 on up. Let's go write that down. So how did this change? From the parent function compared to the parent function, it shifts left and right. Okay, how did the axis of symmetry change? It also shifted left and right. So if my graph shifted left, my axis of symmetry shifted left. What about the vertex? Well, yes, that changed. Okay, but this time the x value changed. So it changed the x value. What about my domain? Nope, didn't change, so it's still all real numbers. What about the range? The range didn't change either, because remember your graph, all of them went from right here. All of them went from off that x-axis. So your range, no change. So that means y is greater than 0, or in interval notation, that would be 0 to infinity. Okay, so what we were dealing with on that first sheet is notice that we were shifting up and down. We're going to call that K. Okay, so K shifts it up and down. And H shifts it left and right. Okay, and so what's going to happen, your equation is going to look like this. We're going to have absolute value of x minus h, because notice that it went opposite. Oh, look at this. So not only are parentheses an opposite machine, but an absolute value signs can also. And then it's going to be plus k. So you're always going to go the opposite. This is always going to go the opposite. Opposite direction than what it seems like it's going to go. Okay, so now to graph these, what we're going to do is we're going to first plot the parent function. Your parent function is what we did right here. And we're going to use these points of 0, 0, 1, 1, negative 1, 1, 2, 2. Okay, we're going to graph those. We're going to plot those first. So we're going to graph that. We're going to not graph it. We're going to plot it. Then we're going to identify what are the shifts. How does it move? Left and right, up and down. And then we're going to actually shift it. We're going to take our parent function, we're going to shift it by that. Okay, so let me show you what I'm talking about. So the first thing I'm going to do here is I'm going to plot the vertex function, the parent function. That's always going to be 0, 0, 1, 1, negative 1, 1, and 2, 2. Negative 2, 2. And all I'm going to do is plot those points. Now what I'm going to do is I'm going to go and say what my shifts are. Well, this one tells me that I'm going to shift down. So my shifts, I shift down 2, and I go left, because it looks like I should go right. I'm going to go left 3. So I'm going to take each one of those points and I'm going to go down 2 and left 3. So each point goes down 2, 1, 2, and it's going to go left 3, 1, 2, 3. So here is my new vertex. Every point goes down 2, left 3. Down 2, left 3. Down 2, left 3. I think you get it now. So now we just complete it. So this is my actual graph. Okay, good. Try the next one. So first, you're going to graph the parent function. Those are those orange dots that you see right here. Whoops, can't see them. The orange dots that you see right there. Plot those points. Go. Write down your shifts. Go. So hopefully you plotted your 5 points, okay? And then you decided your shifts, it was down 3 because there's a minus. And then because I have a negative 1, it's going to be right 1. So now we're going to take each one of these points, shift it down 3, and right 1, go. When you made your shift, your graph would come out looking like this. Good. So I'd like you to try these two right now. Okay, plot the parent function, use the shifts. If you're not sure, look back over here on what happened. Go. Here's number 3. Here's my parent function plotted, and then my shifts are up 4 and left 5. Now, it doesn't matter which order you do these in. You can write left 5 and up 4. It doesn't matter. But I'm going to go up 4, left, or else I'm going to go left 5 and up 4. Okay, so let's look at this one together. We're going to plot the parent function. Let me show you one other thing. So now look at your shifts. My shift is going to go right 6 and up 2. Okay? So what I'm going to do is I'm going to show you with the vertex. I'm going to go right 6, 1, 2, 3, 4, 5, 6, and I'm going to go up 2. Okay? Now the other thing I can do with this is I can just take the parent function and I can shift my entire thing right over here. So notice I went up 1 and over 1 and up 1 and over 2. Sorry. I went up 1 and over 1. I went over 2 and up 2. So from here, I can go over 2 and up 2. So if you're tired of carrying every point, you can just kind of regraph it right over here. If that didn't make sense, then go back to what we were doing to begin with. Plot the parent function and shift them all. Okay? So what we're going to go on to now is we're going to see what happens next. So we're going to go back out to Desmos. You're going to plot your parent function. It should probably already be plotted. And then I want you to just do this one. Okay? Go. Back out to Desmos. So when you went out to Desmos, the red one again is our parent function. For me anyway, it's red. Okay? And then the purple one is my new function, y is equal to the negative absolute value of x. And look what happened. Okay? What happened? Write that on your paper. What happened? Hopefully you wrote, hey, it flipped. What we say is it opened down. So the red one opens up. The purple one opens down is the way we talk about it. So it opens down. You're all going, it just flipped, which it did. When it flips, though, it opens up and down. Okay? So let's go back to our notes. Whoops. So for this one right here, okay, that graph looks like this. And this graph does this, right? So we say that this opens up. It opens up. And this one opens down. Okay? So opens up, opens down. So what happened? It flips. Flipped over the axis. Okay? Now, just to be sure, graph these two and see what happens. So go back out to Desmos and see what really happens. What happens with this? Okay? And while you're there, actually, play with this one too. See if you can see what is happening with all of those. So I just did the first equation, y equals negative absolute value of x plus 3. So here is my red one, my parent function. So it flipped it, okay, and it also shifted. So that's one of the, so it opens down now. My graph opens down. It flips it to open down, and it shifts it over 3. Okay? Try that second one. I think you'll see. Or if you want to, I'm just going to go to that third equation. Y equals the absolute value, negative absolute value of x, but I'm going to go plus 1. Okay, that one came out, and I want to change that color so we can see it. So now, if I look at my functions, my red one is my parent function. My green one, it opened down, so it flipped it, and then it went up 1. So it's gonna do everything the same. It's still gonna shift it left and right and up and down, but it's gonna flip it over also. So when we look at that, what did it do? This one flipped, so it opened down, flipped, and it's going to shift to the left 3. This one would have opened down, shift to the right 2. This one opened down, but it shifted up 2. And we're going to stop there for now. So we're going to look at the next couple pages, and we're going to skip over that page too for now. We'll maybe come back to that later. So what I want you to do is that you're going to now go and do this homework. You're going to look at what your shifts are for each of these. You're going to try it, and I would recommend doing the same thing. Plot the parent function, write down the shifts, and then do it. Okay, so you're going to do 1 through 4. For now, you are going to skip 5, and you're going to do 6. Okay, but I also want you to look down here. We're going to write the equation for each compared to this. So this is what you're going to be doing for homework. I'm going to make up another one over here, and I'm going to make up that we have it, that it shifts, we'll go 2, and it's going to go down. So if it shifts down 2, think about what is that affecting? It's affecting that number on the outside. It's affecting k. So this equation would be y equals the absolute value of x, because it just shifts up and down, and it's going to go up, so it's going to be, it's going to go down, so it's going to be minus 2. Okay? If I have one that goes left 5, well, that means that it affects what's inside the absolute value. It's going to go left, so that means I have to go the opposite direction 5. That would be my answer. Now, these are going to do more than one thing. I'm just going to take this one right here. Left 4 and 7 up. 7 up. So left is going to affect what's on the inside. And if it goes left, it's going to go the opposite. So that's going to be a plus 4, because it's the opposite. Left is negative, but I'm going to have to put a plus here. And then it goes up 7, so plus 7. Okay, that's what your equation would look like. So for your homework, you're going to do 1, 2, 3, 4, and 6, and then 9 through 18. If I numbered them right. Hopefully I did. Great. Okay, go work on those, please. If you have questions, you know where to find us.